In this question, it tells us that the straight line between A, north 75, east 166, and B, north 78, east 154, is drawn on a chart. The true track angle of the rhumb line at B is 317 degrees true. Calculate the direction of the straight line at position A. Now, for this question, we do not need to draw a polar stereographic diagram like we normally would. And the reason for that is we know the value of the rhumb line track. We could actually draw this out as we would any normal convergency problem. So in the northern hemisphere, your meridians converge at the top. We could draw these to converge at the North Pole, but there's no requirement for that. So we know that this one is east 166, and this meridian is east 154. We also have a great circle track running between two positions, and that great circle track is running from east 166 to east 154, so it's a westerly track. The question is asking us for the value of the great circle track at position A. Therefore, that is this position. A is at east 166. So we come to the north side and we go clockwise all the way around to the track line in the direction of travel. So this is the question mark over the angle that we're looking for. This is our problem. How do we calculate that angle? Well, the question also tells us that the rhumb line between the two positions, or rather at position B, is 317 degrees true. Now, the rhumb line is always drawn on the equatorial side of the great circle. So there's my rhumb line between the same two positions, and we're told that the rhumb line at B is 317 degrees true. But you will remember that the number one property of a rhumb line is that it is a track of constant bearing. Therefore, if it is 317 degrees true at B, it's 317 degrees true at A. Now the question is asking me to calculate the direction of the straight line at position A. So this is position A. So we can see that the great circle is greater than the rhumb line. So great circle A is greater than rhumb line A. Therefore, it's greater than 317 degrees true. Therefore, we must add something to it. And the difference between the rhumb line and the great circle is this angle in here, which is known as conversion angle. Now, conversion angle is equal to half of convergency. And convergency on a polar stereographic chart is simply change of longitude, delta lambda. The change of longitude between east 166 and east 154, equal hemispheres, so we subtract 166, take away 154 is 12 degrees. So the value of the conversion angle is 6 degrees. So we place that in here, and we add that to the 317 degrees, and that gives me a great circle track bearing at position A of 323 degrees true. Simples.